X-ray interacts with matter. The first one is photoelectric absorption. It happens when the X-ray photon interacts with an inner shell electron. The incident photon ejects the electron from the inner shell and is totally absorbed in the interaction. Photoelectric absorption is more likely to occur with an electron that is more tightly bound in its orbit. The incident photon energy must be greater than the binding energy of the inner shell electron. This results in an ionized atom because of the missing inner shell electron and ejected electron, which is called a photoelectron. The photoelectron travels with kinetic energy, and the vacancy of an inner shell electron is instantly filled by the L shell electron that releases an energy in the form of a characteristic photon called secondary radiation. The second type of interaction is a coherent scattering. There's actually two types of coherent scattering, coherent by Thomson and coherent by Rayleigh. Thomson scattering is when a single electron in the shell is involved, and Rayleigh is when the entire atom as a whole is involved. This interaction occurs between very low energy X-ray photons and matter. When very low energy photons interact with electrons in an atom, it causes them to vibrate at the same frequency as the incident photon, which then causes the atom to release excess energy by producing a scattered photon that has the same energy, frequency, and wavelength as the initial photon, but it travels in another direction. Compton scattering occurs when the incident photon interacts with an outer shell electron. It removes the electron from its shell and proceeds in a completely different direction as a scattered photon. The dislodged electron travels with kinetic energy and is called a recoil electron. The photon that exits the atom is called a Compton scattered photon and has less energy than the incident photon, which means that it has a lower frequency and a longer wavelength. When a scattered photon is deflected back towards the source and is traveling in the opposite direction of the incident photon, it's known as backscatter radiation. The next type of interaction is called pair production. It's when the energy of an X-ray photon is converted to matter in the form of two electrons. This occurs when a very high energy incident photon comes close to a nuclear field and loses all of its energy in the interaction. The energy is used to create a pair of electrons, one with a positive charge and one with a negative charge. When these particles combine, they disappear and produce two photons moving in opposite directions, each possessing an energy of 0.51 MeV. This is known as the annihilation process. Pair production requires a minimum of 1.02 MeV, but it is not significant until approximately 10 MeV. Photodisintegration is an interaction between extremely high energy photons and the nucleus. The very high energy photon strikes the nucleus, and the nucleus absorbs all of its energy. The excited nucleus responds by releasing a nuclear fragment.